So this is 2.8 part 2. So if you ask me to take the derivative of this thing, I'm first going to write down the limit definition. And it's going to be the limit as h goes to 0 of f of x plus h minus f of x over h. And so I come over here in my scratch work and I write out f of x plus h. And so that means you just put in x plus h everywhere where there was an x. So then when I distribute this, I get this. When I distribute my 2, I get this. So now what that's telling you is that f of x plus h is just equal to all of this ugly stuff. So I'm going to move it over here to where it's really clear. Okay. So that means that I can, if I delete this, that means that all of this is just the same as this. So I do the replacement, right? But what I would really have is all of this. Why is this not doing what I want? It would be all of this divided by, it's going to be all of this stuff divided by h, because this is f of x plus h minus f of x all over an h. But instead of divided by h, I'm going to multiply it by 1 over h. So that's going to make everything simpler. But then I have 2 terms that I need to add together. So I'm just going to use a well-chosen one here and a well-chosen one here so that I get a common denominator here. So now this is what I have going on. And so I have all this, I just need to distribute. So I have 4 terms times 2 terms, so I'm going to get 8 terms. I have 2 terms times 3 terms, so that's going to be 6 terms. And so when you distribute this out, you get all of this. When you distribute this out, you get all of this. And then we just need to see how these terms combine together. So let's carefully go through and see how these terms combine together. So let me do this. Okay, so do you see that the 2x cubed and the 2x cubed cancel out? Then the 4x squared h and the minus 2x squared h give me this. And then 2xh squared is right here. And then the minus 2x and the minus 2x cancel out. The minus 3x squared and the minus 3x squared cancel out. So then this would be left, this would be left, and the 3's cancel out, and this would be left. So now I have my 1 times h times all this. If I factor out an h out of everybody in the top, I am just left with everything that you see here. So this is an h factored out of the top, it goes here. And so now this thing out front is just equal to 1. And then if I let h slide to 0, that's going to go to 0, that's going to go to 0, and that's going to go to 0. So that's all that's left on top, that's all that's left on bottom, and that is my derivative function. Next question wants to know, if you have dn over dp, where n is the number of people that are traveling out of state and p is the price of gas, then dn dp, do you think it's going to be positive or negative? Well, I expect, since I write it out nicely, that that's the change in the number of people divided by the change in the price of gas, I would expect that dn dp is going to be negative. So that for every increase in gas prices, I would expect that this would be negative. That would go down. So that's why we got the answer we got. 42 and 44, it says, where is this thing discontinuous? Well, here at x equals -1, not continuous implies not differentiable, so it's not differentiable there. Then it asked here, it's not differentiable because it has a corner. So the limits don't agree. The derivative wants to be positive coming in this way and negative coming in this way. So it just doesn't know what to do right here. Then for 44, we've got a corner here. The derivative is 0, and then all of a sudden it's positive. So since those limits don't agree, this corner means the derivative's not going to exist there. Hey, Celine, if you could do me a huge favor and breathe through your nose, that'd be great. So this, since the derivative is 0 here, and here the derivative is negative, we're going to have a corner here, so it's not going to be differentiable there. So both of those corners. And then here, not continuous means not differentiable. And then last one, it wants to know, if you're looking at this, who is the derivative of who? Well, first thing you notice is, if I look at this one, it crosses and makes a 0 here at the same point where this one has a peak. So I think that the derivative of b is a, because at a b peak, I have a 0 on a. So b, if you take its derivative, you get a. And then working back from that, okay, so if I know that this derivative is that guy, then what is c? Well, if you look at c, it has what looks to be, it looks like it's small, and then it gets bigger and bigger, and then it looks like it has a peak right about here, a horizontal tangent. That's where 0 is right here. And it goes small negative, goes small negative. It looks like c, if you take its derivative, you get b. And so then the last one left is d. How does that fit in? Well, if you look at d, it's 0 slope, and then it gets more and more and more. And then at the end, it looks like it's almost like a constant slope. So if anything, it's going down just a little bit. So it looks like d, if you take its derivative, you get c. So if that's the way that they're related, then this would be position, whose derivative is velocity, whose derivative is acceleration, and whose derivative is jerk. And that's it.